everybody. Today we have a new problem. We have been provided the code for creating a deck of cards. So our task is to sort the deck of cards by suit and by value. The suit should be ordered in the same order in which the deck is created. So we are also we need to create a property that determines whether the deck is sorted or not. So also we need to create another method that will search that will allow the user to describe a card and will return the location of that card. Okay, great. So we have here the class deck. Here we have our array of suits in this order: diamonds, clubs, hearts, and spades. So here we need to go to the class card, and the class card we are gonna override the GT method. This GT method will allow us to know which object card is going to be greater than the other. For example, if we are comparing to one club card compared to a diamond card, then club is going to be greater. Then this method is going to return true. And if the two cards are with the same suit, then we are going to compare values. If the value of the first card is greater than the other, then we are going to return true. Otherwise, we'll return false. So here is our sorting method. We are using bubble sort. The time complexity for bubble sort is squared in the worst case scenario. So here we're having the we're using bubble sort. We can also use insertion sort, but we are using in this case bubble sort. Then we have when we have the property is sorted. Here we are comparing two cards. Two cards. If we don't have it in the order that is specified, then we will return false. Then otherwise we will return true. And then also for the search method, we need to build a dictionary. So and the key of this dictionary is going to be the chosen card. For example, 5 diamonds, and the position is going to tell us in which position is it. For example, it is in the position 4. Then what is need to be returned is this position, no? The position of the position or the key. Of the value of the value for this given key. For this to be a key, we need to, in the class card, we need to override the hash method. And so we're hashing the suit value of the card, or basically the object. We're hashing this to be used as a key in our dictionary. Here I am creating here with a dictionary with this method card position map. Here it's an empty dictionary. I'm putting every card as a key, and then as a value the position of the card. I am calling this card position map in the creation of the deck. Here, for example, I am calling this method card position map, and also when the deck is shuffled, I am also calling the card position map, so I can know where the cards have fallen in which position once the deck is shuffled. So I'm gonna try this. Let's see. Here I am running the code. I'm gonna instantiate the class deck here. So as you see here, the deck is created and is sorted because that's the way it's created. And now I'm gonna shuffle it, and then I'm gonna print the shuffle deck. Here's shuffled. Then let's see the property of so it's sorted. No, it's not sorted. False. Then I'm gonna search for a specific card. For example, I'm gonna search for spades. The number 5 is spades. No, here it is that in the shuffle card, the 5 of spades is in the position 14. Yeah, and then I'm gonna sort the deck. I'm gonna print the sorted deck. Here the deck is sorted, and the deck is sorted. Yes, great. So this is the second part of the problem. We have been provided with several files to create traverse trees. We need to populate a binary search tree using these random numbers in a file. Also, we need to evaluate the number of leaf nodes and also the height of the tree. Here we are using the code provided in order to instantiate our class 3 in this object BST. We're providing all these numbers as the nodes of our tree. In order to evaluate what is the height of the tree, we can use the option of the depth search first traversal. We are using the in order method. We can also use the pre-order method as well. Both go deep into the tree. Here I use the in order function and compare which is the deepest branch, or the left or the right. So here I am comparing the left depth against the right depth, and then I'm adding 1 to the calculation to know what is the height of the tree. Here I am evaluating this function, and here I am getting for this given tree the height is 5. Now for this in order to get the number of leaves, I am using breadth search first. The breadth search first span horizontally to the tree, so we will provide the here a variable quantity of leaves, but how we can define which is a leaf or not. So if the provided node it doesn't have any child to the left or to the right, then it is a leaf. Then we are adding to our variable quantity of leaves a +1. Then we are returning the quantity of leaves here. Here for this given tree that I just evaluated here, I am having 5 leaves. And now specifically for our problem, our file, the random numbers, where I'm inserting here again the tree. So for the tree to be empty again, and then I'm inserting every element of the random number file into our tree. And here I am calling the method in order, or the function in order to get the height of the tree, and then I'm calling the breadth search first traversal function to get the number of leaves. Here the height of the tree is 14 and the number of leaves is 31.